Nice. Glad to be here. Nice to meet everyone. I'm YK, and with me is Grace. So we're glad to be here to talk about this topic here today, combating the struggles of modern cloud native Java developers.
Let me go ahead and share my screen. Sorry.
No worries.
My Wi-Fi cut out for a minute there, but hopefully I'm back now.
Yeah, you're back. I can hear you
Always
all
a
right.
challenge with virtual events. Perfect. Thanks, YK. Hopefully you can see the screen.
Yep.
Fabulous. So we're here today to talk about sort of really getting into the details of why we're facing these struggles, what these struggles are, and how things like platform engineering, internal developer platforms, and some of the tools and technologies available to help with this can help us as we make this journey to modern cloud native Java developer. So yeah, as YK said, my name's Grace Jansen. I'm a developer advocate at IBM. I'm based in the UK, and I'm speaking today with YK, who's the other side of the world. So it's all different time zones here today. So it's wonderful to be able to have so many of you from so many different locations joining today. So thank you so much for your time. So we are going to try and get around to questions at the end. There is a chat, so if you have any comments, questions, we'd love to hear them. We're going to try and sort of look at that as we go throughout the presentation. The nice thing about having two speakers is that we can monitor that as we go as well. So please do put your comments in, put your questions in, and we will try and get around to those at the end. If you're not comfortable putting it in the chat, or you come up with something that you want to ask later, our Twitter handles are both on the bottom of this slide and on the end slide. So if you miss them now and want them later, they'll be on the last slide as well. But feel free to reach out to us on Twitter, and we'll get back to any questions you have later on as well. So without further ado, we'll get started. So the question really that I want to start with is, why do we care about moving to the cloud? Why are we making this journey and going through all these struggles? Why are we putting ourselves through it? And I think the sort of key feeling that we get when we go to the cloud is sort of this feeling. Hopefully you've seen Toy Story. If you've been in my other presentations, you might have seen this slide before. I just love it, so I can't take it out. It's this feeling that we get as developers, this, oh, the cloud. We get excited by the cloud because it offers a lot of different innovative technologies and behaviors and characteristics that we can't otherwise, or it's hard to get otherwise, without using cloud native infrastructure. Things like flexibility, portability, resiliency, and increased access to innovative technologies. So we want to be able to make this journey to the cloud for all of these different reasons. However, it doesn't always feel like this when we're actually moving to the cloud. Often it feels a bit more like this. It's frustrating, it's annoying, it's difficult to do, where something might work on our machine locally, not working in the cloud for some reason. So, we're facing a lot of struggles and frustrations and challenges in this move. And so we want to move, hopefully through this presentation, through the methodologies and technologies we're going to introduce, we can move from this back to this feeling of excitement and joy around the cloud native technologies. So what are we going to cover today? We're going to take a look first at how we got here in the first place. So what happened to lead to these struggles? We're going to take a deeper dive into those struggles, and then take a look at platform engineering, internal development platforms, internal development portals, and how these can help us as developers and the benefits that they give us to help with those struggles that we talked about. We're then going to go on to tools to help, so hopefully giving some practical insights into open source and proprietary options that are out there to help us enable these within our organization. And then we're going to have just a quick summary and resource section at the end. There are links throughout this presentation, so feel free to screenshot, or we'll be sharing the links afterwards. And then there's a whole bunch of resources at the end if you want to continue your learning on from here, if it is of interest to you. So that's sort of what we're going to cover today. So we're going to get started going into how the hell we got here. So I'm going to pass on to YK for this.
All right. So as Grace mentioned, supposedly, I presume, moving to cloud should make life easier for developers. And what happened when we talk about cloud and doing cloud native development and so on, it's getting more and more challenging. So what happened? Really, it comes to the notion or the trend to shift left from a developer standpoint, right? So where perhaps starting with DevOps and so on, that the application the code that you wrote, you should build it and then you should run it too, right? So and then and not only that, developers are being asked to consider more and more, right? So that it's not only just your code anymore, right? Not only application development. I mean, previously, obviously, dev and ops were separate, and now with the advent of DevOps, they're coming together. So what you write, you should build and then run it, right? And then there's other more and more considerations for obvious, for instance, security, right? That's DevSecOps, right? So security should be built into what you do from a CI/CD standpoint for your whole DevOps, and then things like even finance or costs becomes a thing now that we need to be considering, right? With FinOps and other things, and all these things are adding more and more onto the shoulders of developers and creating, in a sense, burdens, right? Burdens. And that's the challenge that we have, right? If we look at a view of what we previously have, right, from an organization standpoint, right, traditionally, when it comes to application delivery, right, developers are focused on the applications and the code that you write and the code that we enjoy writing, and then we built it. And then once it's built, right, you more or less hand it over to the ops teams to worry about it and putting it into production, so to speak, right, taking what you have built and tested and deploying that into your production environment. So dev was focused and easier, but obviously a lot of things might be on the shoulders of ops previously, right? But then with DevOps, and when we look at that for modern application delivery or expectations from a cloud native application development and deployment standpoint, right? It's a different story, right? So dev, as mentioned, right, the move to shift left, the developers are being asked to do more and more, right? Not only you have to worry about your code, the design of that, and the usability of what you are writing. You're being, well, essentially what you built, what you write, what you built, should be running it, right? So you have to worry about more and more stuff around, okay, where my code will run, right? The cloud environments, the runtime I should be using, and all these things. And obviously, ops still have a role to play, but they may be scratching their head because it's really a shift in how we do application delivery, right? And so that's really and this is a good quote from Luca from Humanitech, right? So the movement of shift left actually forces developers to have, I guess, more and more to know more and more stuff and to handle more and more kinds of tools and including complex workflows and so on. And many times, right, these tools or what we need to deal with here with DevOps and the shift left movement, right, it's infrastructure centric, or it could be specific to a particular platform environment, right, that you may be running your code on. So it's additional cognitive load onto the shoulders of developers, right? And even if we have tools, there are many choices, and that's also a challenge in itself, right? Well, tools may help, supposedly, for instance, the ICD pipelines and things like that, they are out there, right? It's meant to help us, but then there is a plethora of many choices out there, right? And when we have that, that becomes a challenge too, right? If this is a picture, I mean, this is the cloud native landscape, essentially, from the Cloud Native Computing Foundation, right? You can go find it there, right? It's attempt to sort of classify or categorize the different kinds of cloud native tools or answers available or technologies available out there for different purposes to help you to help us actually to pick and choose what we may want to use, right? But just look at this and the number of boxes that we have here, right? Isn't it amazing? And what are we supposed to do with them? Which one should we use, right? And you might be familiar with the classic question, where's Waldo or where's Wally, right? Can anyone tell from this picture where is Wally? So if I was trying hard myself to find it earlier, right? But if you haven't found Wally, it's he's here, right? So he's there, right? So you can just tell from this that there's many tools or many things to consider, and all these have added to the load or the cognitive load and the increasing complexity of things that the developer has to worry about.
Oh, that was quite the diagram. So now that we've taken a look at sort of how we got here, thanks YK for that, let's delve into some of the struggles that that's led to. And YK's kind of alluded to some of these already, but let's take a deeper dive. The first one I want to point out is the CI/CD tooling. I think we've all been through this journey at some point where I quite enjoyed this meme where, you start learning containers and you're getting excited because you're like, I'm getting there. Then you discover Docker and you're like, great, I'm gonna nail this. And then you start understanding Kubernetes. And then you finally get to the top of that peak and realize, actually, there's a whole lot more to cloud native than just containers, Docker, and Kubernetes. And it's a really steep learning curve. It takes a lot of time to be able to actually learn these in enough detail to enable effective CI/CD tooling and pipelines, and to ensure that you're deploying your application efficiently. There are, as YK's already pointed out, too many options as well when it comes to trying to pick out the frameworks and the libraries and the tools that you're making use of. Even when it comes to open source standards, there are still lots and lots of choice. There isn't just one single standard in this regard. And then on top of that, we have to worry about observability now that we're deploying this into a more distributed and often complex environment in the cloud. Another one is container management. One does not simply run a container. There's a lot more to it than that. Containers are fantastic in terms of offering us that portability and flexibility, some of those key characteristics that I was talking about before, but there are many, many decisions that are needed in terms of efficiently deploying and maintaining our containers in the cloud. Which tools are we going to be using? How do we configure our environments correctly or efficiently for great performance, for example, and cost reduction? How do we build our apps? Which tools are we going to use for that? And it can be challenging when you have the ability to be able to sort of enable each of your teams that might be building different parts of the application to deploy using containers to be able to ensure you have consistency and that you're sticking to best practices across your whole organization. This can be quite challenging when it comes to container management. There are tools available to help with this, so things like operators and cloud native build packs can help in terms of enabling you to utilize, say, the same images, for example. In fact, if you've not come across the cloud native build packs, there is an article at the bottom here that I've linked to introducing that topic. So check that out if you're interested in that. However, these don't sort of tackle all the issues involved in this section. And the final one is sort of leading on from that, this sort of consistency and best practices. How do you ensure security and regulatory requirements? This is another struggle that we face as developers. As YK was saying, we've also got this shift, not just DevOps now, but also talking about security and other elements as well. We need to be aware of the different compliance and regulatory requirements, depending on what data we're dealing with, for example, where we're storing our data, where our organization is based, what geos our customers are in. So we need to be aware of this and ensuring that we have that compliance baked into our application software development lifecycle. We also need to be aware that we're using more and more open source software, which is fantastic, but we need to understand and be aware of what's in our application. Do we trust it? Do we have a trusted software supply chain? Do we have a software bill of materials so that we're aware what's in our application and what potential vulnerability we might have if there's, say, a sort of a security vulnerability within that library? And that's not just within external libraries, but also vulnerability awareness within our own source code, any images we're making use of, as well as those external libraries. We also need to understand that, are we scanning our own application? Are we being aware that, do we have any compromised credentials within our code itself? And are we authentication and authorizing people correctly when it comes to enabling access to the different elements within our application? So there's a hell of a lot to think about here. And these are all struggles that we face as developers. And as if this wasn't enough, there's even more struggles. So for example, you're likely already drowning in scripts when it comes to actually enabling. If you're already utilizing cloud native, you're probably also likely drowning in these scripts and subsequently the maintenance costs of those. You might today just say you'll hire someone from DevOps, but this doesn't really scale at large. On top of that, it can be very difficult, no matter how hard you try, to reach the degree of automation that you want, because again, this issue of scale. There's also often a key person dependency, another struggle we face. Any maintenance update normally depends on someone who knows exactly what config to change and in what file. But the issue is, the average time in our job industry is 1.4 years. So if we're changing someone every 1.4 years and it takes time to upskill them, into knowing where that config is, what files they're in, it's very difficult for us to have this key person dependency because that person will keep changing potentially, and we have to have this sort of period of learning as well. On top of that, it can be a very long time potentially to actually create a new environment for devs. Every time a dev needs a new environment, often they have to interrupt a colleague in ops, wait for its creation. In fact, in some of the most extreme examples, this is from a blog from Humanitech, these extra struggles. And in that blog, Humanitech found that in the most extreme example, they found that it took an automotive company 3 months per process. That is a long time to be waiting for a new environment. And then on top of that, you can also get obviously environments blocked by testing. So if you need to ship something, you can't, and you have to run a hotfix, your team is out of the game entirely. So these are even more struggles that we're facing moving to this cloud native environment. And what all of this comes to feel like is a bit like this. I don't want to do it anymore. I don't want to face it. I don't want to be building cloud native. And it's not just me feeling this way. There's lots of studies out there that show that this is how developers are feeling. In fact, this is a study by Salesforce back in 2022, so not that long ago, talking about the top 3 causes of developer burnouts, being some of the things that we've mentioned already, some of these struggles. Increased workload, normally from other teams, so that shift left that YK was talking about, pressure of this digital transformation, pressure of moving to this cloud native infrastructure away from our more traditional style of application development. And the third one, requirement to learn new skills. As I mentioned, it's a steep learning curve for many of these because it is an entirely new way to develop applications. And there's a huge plethora of tools that we need to get our heads around, as well as the architecture itself. So it is a big requirement for us to be upskilling on all of these tools quite frequently. In fact, 76% of organizations in this study said that this cognitive load that we've been talking about caused high angst and low productivity for developers. So double whammy in terms of the developers were worse off in terms of happiness, enjoying their jobs, but also the organization was worse off because developers weren't able to be as productive because of this burnout and this angst. And in fact, there was a great, if you want to check out the study, by the way, I have linked to it at the bottom there. But there was actually a great post, again, this is by Luca, that dev advocate from Humanitech. He did this on Twitter. And it's quite interesting to see devs' reaction to, do we actually want to be doing the ops side of things? Is that something we want to take on? Or is it something that we've just been sort of asked to because we have to now with this shift left mentality? And it was interesting. I mean, some of the results were quite extreme here, but it's interesting to see that the majority is either no or I don't care, not necessarily jumping at the bait to really take on those ops responsibilities. So together you can start to see this picture of we've got this increasing cognitive load, lower productivity, more angst, more burnout, and we don't necessarily want to be taking on all of these responsibilities. So what can we do about this, and how can we sort of enable this reduction in these struggles and help developers when it comes to these challenges and issues?
Right. So is it all gloom and doom, or is there an answer or a solution to the problem here, or the challenges that developers are facing today, right? And really that's what platform engineering is about, right? If we look at what Gartner has put together in terms of what's coming or what's emerging in terms of trends or technologies, right? So this is a recent view of what we have for software engineering, right? So platform engineering has been identified as one of the emerging trends or approach to solve this problem or to deal with this problem of cognitive overload and challenges that modern cloud native Java developers or developers in general have, right, with dealing with cloud native application development and deployments. And so what is platform engineering, right? This is a definition from platformengineering.org. There are additional resources there that you're all invited and welcome to check out. And it's really about building a platform to make life easier for developers to focus on their application and to put together, right, based on tool chains and or even best practices that or golden paths that an organization that has considered to be what they should have and that should put together to make it easier for developers in a self-service manner, right, to provision and deploy the applications that they are working on, right, easily, right? So where there will be a platform that's being built and provided to developers, referring to as the internal developer platform, right? Focusing on covering the more operational aspects of things, and where developers can easily access and use to build and deploy the applications, right? So that's platform engineering, and it's been it's one of the things that we should understand and watch out for, and actually get our hands wet with it, right? So if we dive into it a bit more, right, does this mean that DevOps is no longer relevant? No, that's not the case, right? DevOps is not that. And yes, platform engineering is emerging, and it's an answer to, is one of the answers to considerations or paradigm, right, to deal with the challenges or the struggles of the cognitive overload and burdens on the developer today, right? But at the same time, it doesn't mean that it's going to supersede DevOps, or DevOps is no longer relevant. In fact, contrary, right? Contrary to that, right? Really, platform engineering uses DevOps best practices and tools to build the platforms to make it easier for developers to get what they need and to focus on what they need to do, right? To simplify the load, or elevate or reduce the load on the developers' shoulders, right? So if we peel the onion further and look into it, right, some of the conceptually what platform engineering is about, right? So there are considerations that we should keep in mind as we look at platform engineering, or building an internal developer platform to help developers do their job, right? It's there's security, obviously, right? CI/CD pipelines, or pipelines in general, is a core part of that, to make it easier for developers to handle continuous integration and deployments, right? Provisioning, connectivity, and orchestration to deal with the underlying platforms or deployments of the applications or the cloud environments that you need to work with, right? These things are obvious, and that's part of what platform engineering should have, we need to consider there. And certainly, last but not least, observability, because it's important for us to understand end to end, right? How the applications are doing, right? So that's that. So these are sort of high level pillars or concepts or considerations that we should have in mind. And if we dig into it further, right? So some of the things that would help with building a developer platform, internal developer platform, when it comes to platform engineering, right? So these are some of the ingredients or different components to consider. Obviously, you have your IDEs that developers work with, right? And then you have your version control, right? In terms of how you do source version control of your source code and so on, right? And you have to consider the resources that you need to work with.
Platform.
So,
Ja, geht halt darum, wenn man schon ja immer mehr gemacht werden.
So I think that it's probably someone. If you don't mind muting
I think they
yourself, that
forgot
would
to
be
mute.
good. Yeah, no worries about that. Yeah. So and then there are things like runtimes and frameworks that you should
I've
use
muted them.
for your applications. Right, runtimes and frameworks that you should use, what your organization considers as what you should have, right, be provided to developers, obviously with security in mind, right? Grace talk about securing things, right? You need to make sure what you're using in terms of a dependency and things like that. You need to consider security there, and then obviously the different aspects of things like containers, Kubernetes, even observabilities, right? Tools to monitor, and then obviously what you should have in terms of pipelines, whether you're doing CI, CD, or GitOps, or things like that, or even infrastructure as code, right? When it comes to the provisioning and bringing up your new environments, right? So these would be different componentry or different aspects when it comes to the underlying components to consider to build. To do platform engineering and to build an internal developer platform to make life easier for developers, right? So with these in mind, then you would attempt to make your own platform, right? To build your own platform to make life easier to help your developers. And so the organization view would be so instead of we show the earlier views where developers will take on more and more, right? When it comes to DevOps and things like that, and the shift left and with platform engineering, right? So it's still DevOps. There are still tools available and different aspects or facets of it that we should consider. But platform engineering will come in to provide an internal development platform, and perhaps through an internal developer portal for developers to use to make it easier for developers to focus on their code at the same, and then build and deploy what they have, right, in terms of applications. And Grace will then now take us to dive into some of these terms like IDP and so on further.
Great. So we kind of saw that architecture diagram here where, as YK was saying, you've got these ingredients, you're baking it together into this internal development platform, and the platform engineering team is then enabling that for developers through things like the internal developer platform and the internal developer portal. But these terms can often get mixed up, and it can be difficult to understand where one starts and stops and how they integrate together. So we're going to deep dive into this just so we get a clear understanding of the difference between these two and what they actually mean and enable for developers. So in this case, we're referring to the internal developer platform as the IDP. You might see blogs and material online that refers to the internal developer portal as an IDP. We're in tech. We absolutely love acronyms. It's just a little bit confusing when we use the same acronym for very similar terms. It's kind of interchangeable. It's up to you as to which one you refer to as an IDP. But in this presentation, we're specifically referring to the platform with the acronym IDP, not the portal. So just to bear that in mind. So what is this platform? Here's the definition that I've got here. And there's some sections in bold really to pull out the key elements of this. I borrowed this diagram from Configure 8. They're an organization who offers a proprietary offering around this subject, and we'll go on to that in a bit more detail later. But as you can see, it's this sort of central component here that connects in with those ingredients that YK was talking about that you can see around the outside that are coming together in those sort of paved paths or golden paths that YK mentioned that are enabled through this central platform. So the IDP is really a central collection of tools, services, and those automated workflows, so golden paths, that enable us to be able to provide a service layer, extracting away the complexities of things like infrastructure management and app configuration. So what it really allows us to do is, again, as YK is mentioning, make it much easier for developers to be able to deploy and sort of get their application up and working, rather than having to focus on how do we enable the infrastructure or the configuration underneath. There are three key components to the naming of this element, and that's internal developer platform. This has been deliberately named. There were lots of iterations of this name. This is the one that's kind of stuck because it really helps to emphasize what this is all about. Internal, so really clearly separating from externally facing platforms. So you might come across Twilio's developer platform, for example. That's really external facing. IDPs are meant to be internal use only. It is for your internal developer department. And that leads on to the second term, developer. This is really emphasizing the focus that this is your internal customer and the primary user of this platform, your application developers. So emphasizing who you are building this for. And the third one, platform, just characterizing the product type that we're creating here. So bear that in mind in terms of if you are considering building one, or at least understanding what this is all about. It's about having this internal view specifically for developers as your primary user and enabling this through a platform. So how do we actually use this as developers? IDPs normally integrate into our existing workflows. So normally it remains as sort of this git push deploy workflow that we see in many different application and software development lifecycles, but it adds that sort of further automation element. So now the deployment process with an IDP is at the disposal of the developer. They can request resources, they can spin up fully provisioned environments, roll back, deploy, and set deployment automation all autonomously through this IDP. So there's kind of only three panes of glass that a developer should really be interacting with and enabling. So the first is the IDE to code in. The second is that git merge to be able to actually merge your application and merge those code changes. And the third is that IDP to be able to ship. So that IDP enables a lot of automation in the shipping and deployment element here. So really, it should be as simple as these three panes of glass, hopefully. So then I'm going to move on to, okay, we've looked at the internal developer platform. What is the internal developer portal and how do they interact? So depending on the maturity of the IDP, there are several different interfaces and access points that you might have to it. This can be either just a simple CLI, or it can be different kinds of user interfaces or a developer portal, like here. So what is an internal development portal? So really, this is the interface or the face of the internal development platform, this single point of access through which we can, as developers, access all of those self-service operations and actions, and also enable that single UI through which to see metrics and observability insights about our application and underlying infrastructure. So you can see again in the diagram from configure 8 here, it's sort of this front-facing element that allows us to have that single point of access, that single interface through which we can access the internal developer platform and all of those automated workflows, for example, golden paths and resources. So that's where the internal developer portal comes into it. So the important thing here to remember is they're not the same thing. They're not interchangeable. We have the internal developer platform and the internal developer portal. Both can be used together to be able to enable platform engineering within your organization and hopefully help developers to make their lives a bit easier. So now YK is going to delve into exactly how this can benefit us as developers.
Right. So with platform engineering comes obviously the internal developer platform and perhaps an internal developer portal to make life easier for developers. And are there any benefits to that? And yes, so from an organization standpoint, right? So you would say, well, developers will continue to focus on the applications. The platform comes in through the platform engineering team or provider, right? Depending on how you look at it, right? We'll handle the aspects related to the platform that developers will use to do CI/CD, right? And so developers can focus on the applications, and then ops will focus on the more infrastructure related elements of the whole infrastructure that you have for your IT, right? So then hopefully, then everybody will be happy, right? From a benefit standpoint, qualitatively, right? And you will be working with golden paths, right? Pay paths, or what do you call it? Best practices, if you will, for at least for your organizations in terms of having at least a majority of standardized in terms of your tooling or tool chains or even how you would deploy and so on, right? So these would be golden paths, right? That your organization will have and make available to developers to work with, right? That's a great benefits, not in terms of time, but also in terms of ensuring that everyone is doing the things that they should be doing and using the best practices, right? The same time, obviously, through the IDP or the internal developer platform, development teams will become self-sustainable, and then they will be responsible for what they need to use from an environment standpoint, right? So easily through the portal, perhaps to the IDP, then they can bring up what they need and everything will be there for them, then make life easier and reducing not only the load, but also in terms of the angst that developers may be facing, right? In terms of dealing with needing to provision things themselves and messing with infrastructure items, right? And overall, I mean, it's really about making life easier from a developer experience standpoint for developers, right? And there are some numbers and studies that different companies have done in terms of benefits, right? So as you can see, this is a view from Humanitech, right? For developers itself, right? You can see the before and after, just for example, right? Waiting times to get environments, right? It's been much faster and easier, right? And also even onboarding time for new developers, right? In terms of understanding how they would get things going, right? It's been much reduced with the help of platform engineering and an IDP, right? What about for the organizations? And there are benefits to the overall organizations too, right? So this is not the only study, but we are showing a view of here. You can look at other studies out there that even other organizations have done, right? Even for the organizations, obviously this is about speed to delivery, right? Faster time to market and lower TCO overall. And is it all good? That's clearly no, I realize, right? There are things that we still need to keep in mind. Yes, developers are happier, reduce cognitive load, better satisfaction, improve developer experience overall. That's a good side of it. But at the same time, right? It's really about it's platform engineering. So there's a new platform here in a sense, right? While it's internal, but it's still a new platform, right? So there will be challenges, right? So you need to worry about building that platform, right? Different aspects of that. And then depending on organization, is it worth it? Can you do it? How much standardization, how much alignment, and what sort of compliance governance that you need to have over things, right? So then that becomes a problem, or these become challenges to the platform engineering teams, and then what we need to deal with, right? And are there answers or tools to help? And Grace will take us through that.
Yeah, perfect. Thanks, YK. So we've seen sort of like the struggles we're facing, what platform engineering is, what IDPs are, what the internal developer portals are, and how they can benefit us, not just as developers, but as organizations. So how can we enable that with tools that are already available? Because this can be a fairly complex process. As YK mentioned, it is still challenging. You are still building a whole new platform. So let's take a look at some of the tools and technologies out there that can help us sort of get started and consider enabling this in our own organizations. So first up is reference architectures. It can be quite hard knowing where to start. Just getting off that starting block can be a bit of a challenge. So actually McKinsey & Co, they are in the bottom right-hand diagram here. They spoke at PlatformCon 2023, and they actually did a bunch of research looking at hundreds of different real-life platform setups, and they uncovered these common patterns in IDP architectures that they then distilled down into 5 architectural planes differentiated by scope, as you can see in the diagram here. So you can see these subgroups that I've kind of highlighted on the left-hand side there. So we've got the developer plane, integration and delivery, monitoring and logging, security and resource. And these have actually been adopted in other reference architectures. So for example, Humanitech has some for the specific cloud platforms. So they've got a reference architecture for AWS, GCP, and Azure. So if you're already committed to one of those cloud platforms, it might be worth checking out those reference architectures specific for those platforms. And they're all available as PDFs that you can download and check out. And it just gives you that starting point from which to check out what other people have done, what tools they've used for the various different elements involved in creating this IDP. Platformengineering.org, where we got that definition for what platform engineering is, they expanded McKinsey's original IDP reference architecture and have now created this tooling landscape. So kind of similar to what we saw with the CNCF, but specifically for IDPs here. It includes the same umbrella subgroupings that we saw in the previous reference architectures, but it also includes some other pluggable tools and is designed to be a bit more sort of vendor neutral in this regard. But again, really useful starting blueprint to help prevent that kind of roadblock to just getting started with the tool. So really useful resources if you want to know sort of what other people are doing, what tools they're utilizing, and what planes or subgroupings you need to consider when building out an IDP. In terms of open source tools that are available, there is Backstage. So this is quite popular and it's growing in interest tool. It was originally donated by Spotify. It's now a CNCF incubating project and really allows an open platform for building developer portals. I should mention here that there is no single tool that will enable a whole IDP for you. Really, it's about combining multiple tools together to, as YK mentioned, bake together your own platform. However, there are tools that can help with the portal side of things or can help enable that baking together of those ingredients. And Backstage is one of these. So it enables this sort of centralized software catalog from which you can pick together all of these ingredients and provides this sort of portal view for you to enable your developers to access all of those pre-configured and sort of golden paths that you've worked out. The great thing about Backstage is that there's a growing community of customizable plugins from various different tools that are already out there that you might already be using in your CI/CD pipeline, for example. Out of the box with Backstage, you get the software catalog. So that's for managing all of your software. The software templates, that allows you to quickly spin up new projects and also standardize your tooling. And you get the tech docs, making it easier to create, maintain, find, and use technical documentation. It's kind of like a docs-like code approach. So these 3 things are what you get out of the box with Backstage, a really cool open source technology to check out if you're interested in this. Building on top of that, we have Janus. This, or Janus, I'm not entirely sure how you pronounce that one. So pronounce it as you like, but Janus, this is a Red Hat sponsored community project. Again, open source. It extends Backstage. So it enables sort of enhanced golden paths and additional plugins to what's available just through Backstage. It's there to provide, again, a highly configurable and secure development portal and that software catalog as well for you to be able to sort of put together these building blocks and control what components can be built together in your IDP. building on top of Janus, we have the Red Hat Developer Hub. So you can see how these start to build on top of each other, and they're the downstream components. So this is an enterprise-grade developer platform for building these developer portals. One thing to note about this is that it's currently only available to a limited set of customers. They were hoping it would be out in the last half of this year, which is kind of coming to a close now. So hopefully it'll be out soon. But they do recommend, if you're interested in this, to check out Janus, because it's the downstream open source component of it. But essentially, this is building on top of Janus, which builds on top of Backstage, and again provides additional functionality through sort of predefined supported plugins and opinionated frameworks. So if you do want to check this out, there is a great video which shows you a preview of that, which I've got on the right-hand side here. Another open source project which takes things from a kind of different standpoint or different perspective or different sort of methodology to enable an IDP here is Kratix. So this was originally an open source project donated by Syntasso, and this enables sort of building internal platforms on Kubernetes through something called promises. So it's this co-creation between development and platform engineering teams through promises, which allows your IDP to be created. A promise is normally consisting of 3 different elements: an API, a set of dependencies, and workflows, so business logic required when a resource is requested. By creating these promises, you can then create the paved paths within your IDP. So just a different way of doing things. And if you've not come across this before, there's a link at the bottom here which takes you to a video, a lightboard video that takes you through what Kratix is and how it can be used. Other options available, I've mentioned a few of these organizations. Some of the diagrams were in our slides. So Configurate, for example, Port, Cortex, Rodi, Ops Levels. These are all organizations offering proprietary products and services to be able to enable IDPs. There's actually a list on internal developerplatform.org where you can check out lots of different options available in terms of tools that you can make use of to create your IDP. A lot of them offer similar capabilities and functionality to the tools we've already mentioned, like Backstage and Kratix, etc. One thing to consider here when it comes to tooling and which option is best for you, how to enable it in your organization, is that there's a whole spectrum of ways to implement IDPs. Now, depending on your organization, you might fall anywhere on this spectrum. If you are a smaller organization and can't necessarily dedicate the resources or don't necessarily have all the skill set to develop out your whole IDP from scratch, you might want to consider the more right-hand side of the spectrum, looking at pre-prepared platform as a service or software as a service offerings that are enabled to be able to sort of pick up an IDP that's already been pre-canned or pre-created for you, so that you can you don't have to dedicate as many resources to creating it from scratch. If you're a large organization and you have more specialized needs in terms of your IDP, then you might be somewhere in the middle here, looking at creating it right from scratch. You might not have a platform engineering team, so you might just be starting off on your journey. There's a lot of different implementations available, but the nice thing is there's lots of different tools out there that can help enable this in your organization, no matter where you fall on this spectrum. It's important to note, as YK said, it's not all roses and sunshine. This is challenging. So make sure that you're picking the right implementation depending on your organization, your application, and your kind of structure in your teams. So we're going to take a quick look before we summarize just at where this is heading in the future.
Right. So based on what we can understand and what we can see, we can anticipate that there will be more and more golden paths available, and perhaps even on the right-hand side of the spectrum, as Grace was saying, right, ready-to-go ones that you can just use, right, especially for potentially perhaps small teams and whatnot, right? Then you don't have to have a whole organization focusing on platform and platform engineering, but you can just pick and work with these ready-to-go golden paths. That's probably something that we can anticipate down the road, right? And then at the same time, right, while yes, we are talking about developers here, and the idea is to make life easier for developers, but the platform itself is actually valuable, right? We can anticipate and we can see that perhaps other personas, other interested parties in the IT, from an IT standpoint, becomes one thing to take advantage of such a platform, right? Whether it's with finance or more on the product side of things and so on, right? So the platform may expand to cater to different needs down the road, and also the possibilities of having APIs available for your IDPs, then where perhaps additional analytics or data can be collected and for further analytics to be done and to make life better and easier going forward for your organizations, right? Using for your IDPs. So yeah, so some of these are some of the things that we see, and so in summary for today, we have had a chance to take a look at the shift left movement in a sense, and the cognitive overload or increasing load cognitively speaking on developers, right? So the complexity in terms of the tools that we need to worry about ever increasing, and more demands on developers on what developers need to worry about. So these are actually the struggles of modern software developer, and certainly including Java developers, right? Are there answers to it, right? Developers can still be supported and be helped with, right? Platform engineering is one of the emerging paradigms to help with that, right? And with platform engineering, we can have internal developer platforms for our developers, making it easier for them to get to what they need when it comes to application delivery and deployment, right? Perhaps through an internal developer portal. And then all these are built around golden paths, right? For your organizations, whether it's your tool chains of choice, or whether it's how you would configure things and the environments the cloud environments that you want to use, right? These golden paths become what your IDP will then offer, right? So the exact solution will be what your organization needs. So keep these in mind and find out what works best for your organization, right? It's a spectrum of answers. Certainly, there are tools, technologies, and even examples, right? Reference architectures out there that we can look at and use as a starting point, if not more, right? And there are a bunch of resources out there that we can look at, right? So these are examples of platform engineering in action from different organizations out there, right? Big and small. So if you are looking for real life examples, you can check them out here. At the same time, obviously, if you want to dive further into the whole domain or topic of platform engineering, here are some useful pointers or resources that you can tap into, or even get connected with the community, right? And so here are additional assets and content that you can read up on, and then including other sessions that experts in this area has done, right? So I've done. So yeah, we're great to be here. Hope you find this session useful. So Grace and I are glad to be here and to have this opportunity and time and chance to talk to you all.